All right, welcome. Today, we are going to tackle one of the absolute cornerstones of algebra, polynomials. Now, I know that word might sound a little intimidating, but trust me, they're everywhere. They're the language we use to describe everything from a company's profit all the way up to the path a rocket takes into space.
So, to get our heads in the game, let's start with a little puzzle. Take a look at this doghouse. Let's say you need to paint the front of it. You've got the main square part, the triangular roof, but you also have to account for the rectangular door that you're not going to paint. So the question is, could you write down one single mathematical expression for the area you need to paint? This is a perfect example of where polynomials come in and make things so much easier.
Okay, before we can solve that doghouse problem, we've got to understand the tools for the job, right? So let's start with the most basic question of all. What even is a polynomial?
So here's the textbook definition. And yeah, it can look a little dense, but the idea behind it is actually pretty simple. All a polynomial is, really, is a bunch of math terms all strung together with plus or minus signs. The one big rule you have to remember is that the exponents on the variables, the little numbers up top, have to be non-negative whole numbers. So an exponent like 2 or 5 or 100, totally fine. But you're not going to see a fraction like 1/2 or a negative number. That's a different beast entirely.
So let's break down what one of these terms actually looks like. Let's take negative 4x cubed, for example. Every little piece here has a special name. The number out front, the negative 4, we call that the coefficient. The letter, x, well, that's our variable. And the little 3 up in the corner, that's the exponent. Pretty much every term you'll see in a polynomial is built just like this.
All right, now that we know the basic anatomy of a polynomial, let's talk about how we can categorize them. It's actually super simple. We just name them based on how many terms they have.
So if you have an expression with just one single term, we call it a monomial. Think mono for one. If it has two terms, like this 2x minus 9, it's a binomial. Bi, like bicycle, 2 wheels, 2 terms. And with 3 terms, you guessed it, it's a trinomial. Tri for 3. Now, once you get past 3 terms, we generally just call it a polynomial. It keeps things simple.
Okay, so inside any polynomial, there's one term that's kind of the star of the show. It's the term with the highest power, the biggest exponent. This one term actually tells us a ton about the entire polynomial.
And from this one special term, we get 3 really important bits of info. The exponent itself, that highest number, is called the degree of the polynomial. The whole term, with its coefficient and variable, is called the leading term. And, no surprise here, the coefficient of that leading term is called the leading coefficient.
Okay, so we know what they are, we know how to name them, now let's actually do something with them. We'll start with adding and subtracting. And the big secret here, it's all about sorting and organizing.
And that sorting is built around this idea of like terms. It's a simple concept. Like terms are just terms that have the exact same variable raised to the exact same power. The coefficients can be different, that's fine. I like to think of it like sorting fruit. You can take 5 apples and add 2 more apples, and you get 7 apples. Easy. But you can't add 5 apples and 3 oranges and call it 8 apple oranges. They're different things. It's the same in algebra. You can combine 5x squared and negative 2x squared, but you can't combine 3x and 3x squared because one is an x and the other is an x squared. They're not like terms.
So the process for adding and subtracting is basically a 3-step dance. Step 1. You look through the whole expression and you find all your like terms. You group them up. Step 2, you just add or subtract the coefficients, the numbers in front. And step 3, for good measure, you write the final answer in what we call standard form, which just means you put the term with the highest exponent first and then go down from there.
All right, let's try one out. Now pay close attention here because this is a subtraction problem. There's one little trap you have to watch out for, and it's this minus sign right here in the middle. You have to remember to distribute that negative to every single term in the second polynomial. It's going to flip all their signs. Once you've done that, it's just back to business as usual. Find your like terms, combine them, and you're done.
All right, we've got addition and subtraction down. Time to level up to multiplication. The main idea here is pretty simple. Every term in the first polynomial has to meet or get multiplied by every term in the second one. It's all about that distributive property. Now, for a super common situation, multiplying 2 binomials, there's a really handy shortcut to help you remember all the steps. It's called the FOIL method. FOIL is just an acronym. It stands for first, outer, inner, last. It's a great way to make sure you multiply everything that needs to be multiplied. Let's see it in action with x plus 7 times 3x minus 5. So f first, we multiply the first terms, x and 3x. That gives us 3x squared. O, outer, we multiply the outside terms, x and negative 5, for negative 5x. I, inner, we multiply the inside terms, 7 and 3x, which is 21x. And finally, last, we multiply the last terms, 7 and negative 5, for negative 35. Then you just look for any like terms. In this case, the negative 5x and 21x. Combine them, and boom, you have your final answer.
So FOIL is great, but there are also a couple of special cases. These little shortcuts that are totally worth memorizing. If you can spot these patterns, you can save a ton of time and honestly avoid some really common mistakes.
Okay, here are the two big ones. On the left, we've got what's called a perfect square trinomial. This happens anytime you square a binomial, multiply it by itself. The pattern is always the same. First term squared, plus 2 times the first and second terms multiplied, plus the last term squared. Then on the right, we have my personal favorite, the difference of squares. This little gem happens when you multiply two binomials that look almost identical, but one has a plus and one has a minus. What happens is that the middle outer and inner terms from FOIL completely cancel each other out. So you're just left with the first term squared minus the second term squared. Super clean. Okay, we have defined what polynomials are. We've added them, we've subtracted them, we've multiplied them. I think it's safe to say we have all the tools we need. So let's head back to that doghouse. Remember where we started? The total area we need to paint is the area of the big square plus the area of the triangle on top minus the area of the door we're cutting out. When we plugged in the formulas for those shapes, we ended up with this expression, 4x squared plus 3/2 x minus x.
And now, after everything we've talked about, this should look way less scary. We just have to spot the like terms. Right here, we've got 3 over 2x and negative x, so we just combine their coefficients. 3/2 minus 1, well, that's just 1/2, which means our final, beautiful, simplified answer for the area is 4x squared plus 1/2 x. And there it is. We took a kind of messy real-world problem and boiled it down to a neat, simple binomial.
And the crucial thing to take away from all this is that it's not just about doghouses or homework problems. Polynomials are a fundamental language. It's what physicists, engineers, and financial analysts use to model and make sense of the world. From a simple shape to the complex orbit of a planet, polynomials are the tool we use to describe it all.
So, we've gone through the basics, what polynomials are and how we can work with them. This is a tool set that really opens up so much more in mathematics. So I want to leave you with a question to chew on. Now that you've got a handle on this